Thank you, Nina, for the space, and hello, everyone. Everybody who is here and is also watching the recording of this video. There was a small miscommunication. I won't be alone at this training session. My colleague, Professor Gabriel Juhas, is joining me, and he is the main person who is having the presentation. I will then make live showcase of the enriched nets or practical experience with our language Petriflow. So Gabo, welcome and thank you for your time. So I will share your slides. Floor is yours.
Okay, thank you very much. As Ľuboš told you, he asked me to help him with the, I would say, theoretical part and maybe a kind of introduction to the topic before he will show you a practical use case, how we can quickly develop an application using our low-code platform and our local language. So the title of this training session is Practical Experience with Petriflow, and we will speak about enriched process model that serves not only as a models, but also as an implementation at the same time. And we will use local language Petriflow, which is, as the name indicates, based on PetriNet that are extended in order to serve as an implementation. And we will use a NetWeave low-code platform to both develop and run the application. Okay, just let me start with two sentences or two statements. First is from 2014, when Forrester came with the term low-code to classify development platforms. Very, I would say, not very precise, just to say that it is something that where you can develop your applications simply and easy. But what is more important, it became actually a Gartner quadrant, low-code as such, and Gartner predicts that in a couple of years, they say in 2026, but it's not as much important whether it will be 1 year earlier or later, local development tools will account for 3 or 4 new application development. In comparison with less than 1 of 4 just 3 or 4 years ago. So if Gartner is right, and usually they are, at least with the direction, if not exactly with years. So we are living in the moment when the paradigms or standard development cycle is changing from traditional programming languages and full stack development to some low-code, no-code development. And we also are observing this trend here because we are approached, like last year, we had a huge amount of different potential partners, software companies, system integrators that came and asked whether we can tell them something about low-code, how it works, and what we think will be a future. So we were actually doing that, and this was also the reason we gave also this talk in Modellierung 2024 conference in Potsdam at Harper-Plattner Institute 2 months ago. So when we were asked whether we could repeat this at this platform. So if we want to predict the future, so it's always nice to take a look to history and actually maybe just interpolate the development from the past to the future. And what we see is the history of programming or application development is that on one side you have a computer or a machine or a set of machines, a network of machines, if you want. And on the other side you have business users or human beings. And the whole story of computer programming is about how the people should tell computer what to do. And why this is a problem? Because from the very beginning, the machines, the computers on software level, not on hardware level, the first level of languages that machines understood was machine code, which actually were tuples of zeros and ones, which was not so understandable and easily readable by human beings. And on the opposite, human beings, people, spoke natural language, which was absolutely not enough precise and therefore not executable by computers. And the whole history is about developing new programming languages from one side, like, okay, first abstraction from machine code was assembler. Yeah, when we abstracted, or people at that time abstracted from exact addresses in computer and used symbolic addresses and symbolic names for commands. And this is from one side, and later on a higher and higher level of abstractions came, resulting in higher and higher level programming languages like C, later object-oriented paradigm with C, C++, and Java as a prominent examples. But then later on, with the coming of internet and World Wide Web, so the applications were not only application for single machines, but more for communicating machines using a network of machines or computer networks. Some machines used by the users, humans, and some other machines may be processing the data that the users entered to the system, to the applications. So client-server architecture became quite prominent. And with client-server architecture, the new languages were emerged. Like for user interface, we have several layers. Now we have a presentation layer, usually in a web browser with HTML and JavaScript, or different extensions of JavaScript like TypeScript and different frameworks like Angular, Vue, or React. Then we have application layers where typically those standard programming languages build the application layer of the full stack that somebody is using, where you have languages like Java or C++. And then you have a data layer where you want to store data persistently. And in that layer, you have typically some relational databases like SQL databases, or maybe also non-relational databases like MongoDB, some document databases, or something like Cassandra, which is a column-based database. So on one side, or one hand, you see the abstraction with the aim of simplification of writing programs or developing applications. But on the other side, it becomes to be more complicated because you have different languages for different part of your system. So now you don't need to program in machine code or in assembler, but on the other hand, you need to know several different languages and several different frameworks to develop your application, such as, for example, e-commerce, e-shop application, or claim processing in insurance company, or e-banking system. So you need actually several different languages and several different platforms, and we do not mention things like DevOps specialists, because you also need to decide whether you will run it on that or that operating system, whether you will run it in cloud or not, whether it will be virtualized or not. So it becomes much more difficult, but people would like to have it much more simpler. On the other side, from the other hand, you also have a tendency to come from specification of application written in natural language to specifications that use some different visual modeling techniques, different diagrams like class diagrams for a data model of your application, or business process modeling and notation diagrams for modeling business processes that you are digitalizing or automating using your application. And from this perspective, low-code languages are nothing more than another level of abstraction, which actually lies somewhere in between today's standard full stack and between modeling techniques like UML or BPMN that are widely used. So it should be probably a little bit more abstract than what we use as a standard today, but it should have more implementation details that some modeling techniques that are used to specify the application in order to be executable. And the question is what to abstract. And the first idea you could have is that we should abstract from those layers. So instead of having several different languages or several different modeling techniques for different layers in your application, you would like to have just one language where all the information will be stored, and you would not be required to specify, for example, imagine that you want to have just a very simple application that your surname is in the system. So you have to define a table in SQL, for example, say person, which has a column called surname. But you also need to have in your application layer Java Bean class with say person too, but with an attribute surname with getters and setters to that attribute. And you need to have a mapping, say in Java persistent or Hibernate, even with annotation, maybe 10 years ago using XML mapping between those two layers, between your table in SQL and that column, and between this entity in Java and that attribute. And if you want to have a front end or user interface for that, in your web browser, you typically need to have a input field in HTML, maybe also with ID surname, and you also probably need to have a JavaScript variable surname, and then you need to use some kind of protocol, for example, HTTPS, and to use the put or get method to send that data which goes from HTML components through JavaScript variable and through that put or to that put to a controller to the attribute person and to the database. So this is actually the candidate to abstraction. So what we propose and what we see should be a future in low-code languages, and actually, when I go back, what traditional low-code platforms did, like I should not name, but what they did, those that are prominent there in the market, they actually didn't abstract from those layers. They just replaced the textual representation of those layers in particular programming languages or scripting languages by visual representation using different types of diagrams. For example, instead of writing SQL script, we are dragging and dropping entity relationship diagrams or class diagrams. Instead of writing the logic of the application in pure Java, we are using BPMN and some BPM platforms such as Camunda, for example, to control the flow of the application. And instead of writing HTML directly, we are using some drag and drop tools where we can design forms for user interface, for example. But those traditional local platforms do not make this abstraction from the layers, usually, typically. So, and what we propose is to make such abstraction and actually to build so-called vertically integrated objects with the principle once is enough. That means when you once define that you will have an attribute surname in your system, your interpreter of your local language should take care about the flow between different layers. So you should not focus on the layers, you should focus on the business logic. Yeah, you should not focus when and why and how the surname will flow from client computer to the server and to the database. This should be automatically done by the platform itself. And once you have such vertically integrated objects, when you have defined all the necessary information about data part of your application, about the logic, application logic, and about the user interface of that object, and you have such vertically integrated objects that contains information for all layers to be generated, then you can make or establish rich relationships between those objects. So now you can establish not only relationships as are typical between data part of the objects, such as foreign keys in databases, but you also can synchronize events on application layer, on execution layer, and you also can use forms as subforms of another forms to build those, to interconnect those objects across layers. And in order to illustrate this on a very small example, we will jump in a few minutes to such an example, but let me just very briefly summarize how we do it. So we actually have some builder, some kind of environment when we can drag and drop those vertically integrated objects. Then we generate a code in the local language, and then we take this code in the local language and deploy this code into interpreter of that language that we call application engine. And to model application layer, to model business processes, we actually use, instead of BPMN, we use extended Petrinets. Why? Because they are executable by nature. So they have explicit representation of states, and actually during class maybe 40 years, all prominent business process modeling frameworks, such as nowadays BPMN, but earlier things like ARIS, event-driven process chains, or different sequence charts in UML and activity diagrams in UML, have semantics in Petrinets that you can find in academic papers. So therefore, we can consider Petrinets as a kind of unifying mathematical framework for business process modeling. So I will not go into details now how we extend that, but we actually use the most prominent extensions of Petrinets that are actually known in literature. So we are not adding new, but we are like taking those that are usually used in the Petrinet community and deploy them to models. Okay, now let me jump to the very simple example. Imagine that you have an order in your company, and you would like to make a process automation of that order. Yeah, and that order has some data such as order number and subject, supplier. So what you would like to buy or what you would like to order from your supplier, and some other information as well, some other data attributes. So you are defining those data attributes, and then you have a life cycle of those data. Not just such a very simple life cycle like create, read, update, delete, but actually a workflow that is telling you how those data are created and when they are created, when the values of those attributes are created and what are their value, and who can, which user can actually perform those tasks that are changing the value of those attributes. So what we actually say that each and every object deserves its own life cycle in form of a workflow process. So here, somehow, we are trying to merge object-oriented approach together with process-oriented approach. Therefore, we call such objects object-driven processes, or you can find in literature that term. So actually, there are objects, data objects, where the data has their own life cycle in form of a workflow process. And it actually is not so important whether this workflow process will be BPMN or event-driven process chain or Petrinet or activity diagram, but it should have activities or tasks as a basic building blocks. So here we have these rectangles represent tasks as our basic building blocks of workflows, and these circles represent in Petrinet states or local states, which are saying me in which state the instance or the object is in the life cycle of that object. For example, here I say, okay, I have a request order approval, so I actually can ask my boss to approve my order, and we say that to each and every task or each and every activity in that process, which are those rectangles, we can associate forms as user interface. So it actually means, and we also have some events, some basic events on those tasks. And those basic events are events like assign a task to a user, finish a task, or cancel a task. And to data attributes, we actually also have some events like set data attribute and get data attribute, where get data attribute actually means that we get the value of that attribute from the server. So it means that if we perform request order approval, then we associate a form to that request order approval, which looks like this, for example, when we have a data attribute, these four green data attributes. And we specify whether we can fill them, whether they are writable or just readable, etc. So we say, for example, we have generated order number, we have subjects. For example, I would like to order Audi A6, Q7, and A3 for my department. Supplier is some supplier of Audi, and I can attach here, for example, a file with the order itself. Or maybe I can generate the file from the attributes that are filled by the person who is requesting. Now, after I will finish the task, actually, my boss gets the task to approve that order, to decide whether I can order these 3 cars for my department or not. So actually, I see that again, here I have these 4 green attributes, but only as readable. And now I also have here a new attribute where I can decide whether it is accepted, rejected, or I will send it back to rework that order. So I'm accepting as a boss. And on the finish of this, I actually can say whether the next state should be accepted or sent back or rejected. So based on the value of this attribute, I will actually send the token, move to the state where it is accepted. So on the finish event, I will actually send the token to this state. So in that way, I will make a decision. And then I can send order to supplier. And then I can, for example, have a kind of bulk approval where I can approve several invoices to that order. So now I mentioned invoices. That means that I also have another kind of objects, which are invoices. And invoices actually also have some data attributes, and also invoices have some life cycle in form of a workflow process. So the first task in that workflow process is to register an invoice, which also has associated a form, because each and every task may have associated a form. And actually a form is nothing more than a subset of data attributes of that object that are displayed to the user with several additional meta informations, like whether you can change the value or whether the value is only readable, etc. Or maybe you have some validation functions associated to each and every reference to the data variable on that form. So for example, here I see, okay, I have an invoice, 65,000 euros. I have a file of that invoice, and here I can actually choose a relationship, a mapping of that invoice to an order. And if I'm taking this order, which is actually this order here, I'm actually establishing on finish event a relationship between those objects in a similar way as I'm doing that in relational databases with foreign keys. And now I can have another two orders, another two invoices for another two cars. Yeah. This was the first one, then is the second one, and then is the third one. So I'm changing here the invoice number. I have now three different invoices that are associated with that order. I can have one-way relationships. I can have two-way relationships. Here I have two-way relationships. That means that the parent object remembers all the child objects in the list of child objects. So I have the freedom to decide how I would like to work with relationships. And now, for example, now I would like to approve invoices. But here I have this bulk approval. So what I can do, I can actually say that I have on this bulk approval reference to these three tasks and use forms of these three tasks as subtasks. That actually means that this task, this bulk approval of an order, will get this form where I will have these three subforms, which are actually forms of these invoices. And in that way, if I'm deciding here, for example, that I will accept the Audi A6, I will say, okay, Q7 we will decide later, and A3 I will reject because we don't need three cars, just two, but we will pay this now, and this will be paid later. So if I'm doing this, I'm actually deciding for those three objects and their life cycle. So in that way, I can build it rich relationships, where actually on finishing that event, I'm finishing all three events of these three subtasks of the tasks, and I'm moving each of that object workflow representing the life cycle of an invoice to appropriate state, either to accept it or reject it, or later is giving it back that I can repeat the approval. And in that way, we actually build these objects and their relationships. And now maybe it's time that Ľuboš will show you a live showcase how you can build that application really fast in the builder, and how you can deploy in the cloud version of the engine.
I just quickly wanted to show also the application that we were describing in slides. So you got there that order and those three invoices. We open that. And as you were saying, here I do have one order that is having three invoices attached to that, and once the user will, for example, change, for example, the state of the decision. So, for example, here where the amount is 89,000, approver change it to accept. Also in the main one, you can see that it was changed to accept. So here I can make a bulk approval, and it was all, these two were accepted, and that one was decided to be checked later. But now let's go to make process-based applications from scratch, demonstrate all the possibilities of our Petriflow language and its local capabilities. We can imagine a showcase where customer wants to have a simple requesting application where external user wants to, for example, have changed something in the internal process. Once some external user will submit the request, registration or the employee on registration will decide whether legal department or some other department will take care of this request. If that department will say that, for example, legal have to deal with that because the request is based on contract, then the PRs or the public relationship officer will write a polite answer to the user. So as Gabriel was saying, our process-based language is Petrinet based. So I will use transitions as tasks to create each form. So in the beginning, I want to put on screen only one task that I will rename to form. And on top of this form, I will create an actual form that will be consisting of all the data that we want to gather from the end client. So the main two text fields will be name and surname. Then I will have, for example, email and telephone number. So email and phone number. And I want to maybe change the few IDs of these text fields. So I will change name to name and, for example, email to email. And what else? I want to put there a bigger text area to gather the text from the user that is submitting a request. So text of the request.
Actually, I believe that you have IDs and titles because you would like to support multi languages. So sometimes title can be actually dependent on which language you are working, but IDs is really a
exactly
field.
And also we are not only deciding whether the data field is having what sort of title or ID, but we also can change the behavior of each data field. So for example, here I want to have email and the text of the request as required, as we do not want user to not fill all these data fields once they will be working with that task. And the last thing is to add there a simple file field with the component of preview, as we also want a user to put there some attachment. So the basic form is done. And now we can start working on the workflow. So in the beginning, we want a user to submit that request. Then we want some person or employee of registration to decide whether it should, for example, go to legal department or skip the legal department, as we only want the public relations to work with that task. So I will here create a simple branch. One will be skip legal, and another one will be go to legal. And the last task will be of the PR department. So in the beginning, submit request. Task for the not registered or not logged user. Then there is a registration registration. Then we'll have two system tasks that will only make the decision. So one is to legal, another one is skip legal. Then we have a legal department, our statement of legal. And here we will have answer of PR department.
Can you maybe also name the states?
Of course.
So it's readable then.
Yeah. So the first state will be initial state. The second one will be requested. Submitted. Then we will have registered. After legal, we will have pre-legal. And after P4, the P4 will call pre-PR, and the P7 will be end. But we also want to have a live status or the status tracker of the application still always available for anyone, also for the not logged user. So we will create a branch here after submit the request. We will use here a special arc that is read arc to allow us to have this task always available once the token is in P8. We will rename the P8 to in progress. So the application is live, and rename the P8 to status of the request or whatever. And once the workflow is done, we can easily simulate it here. I can simulate it by tasks or by transitions or by events. I will use the simulation by events, sorry. So in the beginning, not registered or not logged user will submit a request. The token was taken from initial state. Right now it is behind this task. Once the token was eaten by this transition by this task, a user will be having open form where they will put all the necessary data, and once all the data will be filled, the user will press a finish button, and after this, the same will happen for registration. The status is always available. Here, system by the what user on registration will decide the token will be eaten and finished by to legal or skip legal task systematically, and then the statement of legal will be fill their statement, and in the end, the same will be done by PR department. Now we can go and create the forms of the workflow. So on top of submit a request, we will use a special type of data field, which is a task reference, which is on background a list of transitions, but we can simply put here that the initial value of this task reference is only the task of the main form. So if we want to change the behavior and leave it editable, all the behaviors of the data fields on behind will be left the same way. And by this, we can just put their form.
With the visibility, maybe you can change ID to form.
Yeah.
Or reference to form.
So, you're right. Now we can go to registration step. In registration, we want to reuse the form, the reference of the task form, and also put here a special or another extra data field, which is a Boolean. And this Boolean is decision of whether to legal yes, no, / yes.
So actually, it means that the employee at the registration will actually see that slider.
Yeah.
And then the whole form. But should he can edit the form or?
No, the form should be visible so that person will only see the data of what was submitted.
So actually, this is the way how to see already submitted form.
Exactly.
And instead of dragging and dropping email,
again,
surname and name to each and every form, we are using form as a subform.
Exactly. And we can make like multiple forms that can be reused, but this time only one is available. Or we can make the thing that you were doing in your presentation to reference tasks or forms from different cases. So registration is done. On to legal or skip legal, we do not have to put any form as it is only a task for that will be done by system. But on statement of legal, we also want to reuse the form. That will be again visible, as we do not want a legal department to change any data, but we want this department to fill their statements. So we'll put here a bigger text area that we will call. We do not need to change the ID, but we can rename it state and of legal department. We will make this field required. And it's all we needed to do here. And similar thing will be done in answer of PR, as we want to also reuse here the form. We want to reuse here the statement of legal department, which we in the beginning want to make hidden, as not always the statement of legal will be shown, as also the branch of skip the legal can be used.
Okay. That means if skip legal is decided, it should never be visible.
That's right.
It should stay hidden. But if it goes to legal, it should be changed from hidden to visible.
That's right. But what we want to have here is the answer of the PR department, and this answer will be shown later.
Or maybe you can call it answer,
just answer. You can be my customer, and
Yeah.
I am the developer who is making the first prototype on the first meeting, right?
Mm-hmm.
And what else? We need to create a form on top of status. So again, reuse form. Make it visible. We want to put here special data field of status, as we want to change the status along the creation of the along the workflow changes. And but also the status should be visible, and also the answer of PR department should be visible here. We will change the component of the text area and make it hidden.
Maybe you can change the ID of status.
The status, right?
Yeah, because we will use it.
We'll make some small functions to change it along the creation of application. Actions or roles?
Roles.
Roles.
I would say roles.
Okay, so we need to differentiate who will do what during the application. One of the application will be running. So submit of request will be done by anonymous user, but we need roles of registration, legal department, PR, and system, as there are a few systematic tasks. So I'll create 4 roles. So I'll create a system role. And I will create a registration role.
So there are employees of registration department.
Exactly. Legal department.
There are lawyers.
Legal. Lawyers. Yes. And also system.
System you already have, you don't have
We don't have
PR department.
Public relations. And now we can attach it to each task. So submit of requests, we won't change anything, as we want default and anonymous user to create that. Then we need to differentiate or assign a role to registration. So registration will perform this whole task. We view it, assign it, finish it, etc.
It may do any event.
Any event, yeah.
Task.
To legal will be done by system. Am I blind? Or I didn't create system.
You create system.
Maybe I didn't submit.
Mm-hmm.
Yeah. So form will be done by system. To legal will be done by system as well. And the same goes with skip legal. Statement of legal. Statement of legal will be done by legal department, by lawyers, and answer of PR department will be done by PR department, public relations. And we have assigned all the roles to all the tasks. Now we can go and create actions. So on top of every task is finished, we want the status to be changed to actual state of the stuff that already happened in the workflow.
Actually, you want to change the string
The string, yeah, the string of the. We can also like change it in the future to something more relatable, like enumeration or stepper or something that is maybe better user friendly. But right now, this is the simplest option to just easily change the text of status. And we can change it in the first step, the request was submitted.
So even if you don't know how the API works, you just go to functions and choose basic functions and then or data field or whatever.
There are predefined functions that are working with all the objects and all the functionalities of the
so you are just changing the data field.
That's right. So also the values of the status. I am copying this function. Also, I want to change the request was registered in this step. Once the task of registration was finished, once the statement of legal was filled, I want it to be changed to. I can make it in phase 3. The request was checked by lawyers, and on answer of PR, we want to change it to check your answer below. As once here, the user will, the PR department user will finish the task. In status, we want the answer of PR department to be shown to user.
To be visible.
Be visible. So your answer is below. And also we can put here a simple change behavior function that is also the part of our API. And we want to change the answer visible on task status on T8. When it is true, like here can be some sort of if else statement that can be some condition, yeah. And same thing should be done here in a statement of legal, as we want users to change, or as when the legal is filling out their statement, we want it to be visible in answer of PR. So we want to change data field statement of legal to visible state on answer of PR when this condition is true. And by simple functions we are done. What the last thing that we want to do here is to make that simple decision whether the workflow should go by the upper or lower branch. So on registration here, I will create not in preface, but when the token will be given to next state.
So then it is released and then it goes to registered.
Yeah.
Once it goes to registered, then you would like to automatically execute either to legal or skip legal.
That's right. So I will choose here the condition of data field value equals value, and the data field that we are choosing here is decision. So the Boolean. So whether there will be true or false. So we can maybe also like switch this because this is by default returning true or false.
But you could like as a low code, you could like true, it's true.
So we can make the condition if true equals true, then it is true. And we can put here two asynchronous execution of task. So we want transition of to legal be assigned and finished automatically when this condition is true. So also
otherwise.
And Gabo, I think that we are pretty much done.
Yes, we are pretty much done.
I can quickly rename it here to, for example, identifier of request. We want this to have these initials and title, new request. And we want this
see here that anonymous role is
yeah. The anonymous role is available. So
any task that has no role can be performed by anonymous.
And we can.
This is the generated source code.
That's right.
In the Petriflow language.
So this is the source code of our request application.
Actually, it's XML based, with exception of these actions, which are actually groovy code.
Yeah.
But it is quite readable for also non.
So just quickly to show what's inside. So all we done in the online ID, the application builder that we're working with. Here are the roles, here are the initials or the metadata of the process. Here are all the data, so attachment, decision, etc. Here is the first task of form, and it's the data grid with all the references of the data. And here is, for example, the groovy function that is changing the status of to the request was submitted. Let's go to application engine. The same place where we were running.
You can log out.
Yeah. So the same place where we were running.
So anybody who will go to that web page can register and create own account and play.
I can give that link here to the chat.
Both links also for Builder.
Yeah, so Builder.
You can also find, if you want to install yourself, both tools on GitHub, but you can also play here.
Yeah, so you can sign up, make your own account, or I already have this MDENet showcase, so I can log in. Within this account, we already have the application that Gabriel was describing in the theoretical part, the order and invoices, but quickly, as this is interpreter of the low-code Petriflow application, I can go here to management and to processes and upload here a new process of this request application. And
it's already deployed. So anybody can use it.
Yeah. And what else can we do? That I can copy this public URL. And as I was saying that we wanted this example to be available by a non-logged user, or I can go to incognito browser tab and put here the URL that I copied.
You can maybe now give this link also to the chat, and anybody can send us his or her request.
Exactly.
So anybody who is there and want to send us some question can do it
by this
just going to that link and send us some request.
Okay.
Or question.
That's right. So, but here we do have a
Slido in 5 minutes.
Slido in 5 minutes.
Yeah.
Or any form of communication with people can be easily done by this. But here is a submit request task that I want to assign as the anonymous user. And here I am able to fill the form. So for example, my name is Ľuboš, surname is Petrovič. My email is required, so I need to fill it. I didn't put there any regex, but I can put there a correct one. My phone number is, for example, this one, and my request text this, and you can put anything here and ask us by this way, and my answer is like change my address in the contract to, and here I could probably put some address information, and I can also put here some attachments. So for example, here is a
like ID, your ID.
Yeah, my ID or whatever
information of the
actual contract
or town that you are, or city that you are a citizen of the village or habitant of the village.
Here is attachment that I put there, and I'm able to finish this task. As I'm allowed to see, there is only the task of status that is allowed for anonymous user. So I can see that the request was submitted. I can see all the data, but it is only visible.
You can click there. And you can
I can download the attachment. And anyone else who I will send this link with also the ID of my process instance will be able to check the data. But not only that, but also all the logged users are able to see. So a few minutes ago, some anonymous user created a new case of my request application. So I'm able to check that. As I do not have other roles than default roles, I can only see the status. But what I can do as administrator of this web application, I'm able to assign a role of registration in the beginning to the user that I'm already logged to. And if I will go back to all cases to check the new case, in the section of in the task of registration, I'm allowed to assign. And here I can decide whether the task should go to legal or to skip the legal department. As I can see, there is a contract mentioned, so I will need to go to legal. And when I will finish, the user who submitted the request can see that the task or the request was registered. And now if I want to check what that branch did, I need to have a role of lawyers. And lawyers will see that there need to be a statement of legal department. And in here, in the statement of legal department, I see that some Ľuboš Petrovič filled it, and I'm like, okay, but there is no new address. And if I will finish, the user will see that the request was checked by lawyers, but there is no answer. And the last one in this process is the public relations, and public relations will see that some user had already that the statement of legal was filled, and they need to answer a nice answer to the client. So, dear client, they will repeat this. And now, when the PR had done their job, the user will see that your answer is below, dear client, but there is no new address. And this way we have created a whole process-based application for getting a request from end users. Okay. I see there is some new one. And thank you, Galo.
Okay, I just wrote you.
You submitted
just some
nice presentation.
You don't need to send it to legal department.
I will probably not, but you will see. Okay.